So good morning, class. Okay, we will start our class. So our topic for today is all about binomial theorem. But before that, we will read first the objectives for this lesson. So at the end of discussion, the students will be able to first define the meaning of binomial theorem. Second, perform the expansion of binomial using binomial theorem. And third, apply Pascal's triangle in the binomial theorem. Okay, let's proceed. So, what is binomial theorem? So, an expression in the form a plus b is called a binomial. So, the statement that for any positive integer n, the nth power of the sum of two numbers a and b may be expressed as the sum of n plus 1 terms of the form. So I will explain it later for you to understand this statement. So there is a pattern of the expansion of binomial theorem. So the first pattern is there are n plus 1 terms. The first is a raised to n and the last is b raised to n. So for example, x plus y raised to 0 equals 1. So any number that the exponent is 0 is equals to 1. Next, x plus y raised to 1 is equals to x plus y. X plus y squared equals x squared plus 2xy plus y squared. And third, x plus y cubed equals x cubed plus 3x squared y plus 3x y squared plus y cubed. So, as you notice, in this pattern, there are n plus 1 terms. So, the exponent here represents the n. So, since this is the first example, the exponent here is 0. So, 0 plus 1 is equals to 1. So, the answer is only have 1 term. Here, the answer is 1 term for the 0 exponent, which is 0 represents as n. So, in this second example, since our exponent here is 1, so n plus 1 is equals to how many terms? So, 1 plus 1, so the answer has 2 terms, which is the x plus y. So, are you following? Okay, let's proceed. For this example, x plus y squared, since the exponent here or our n here is 2, so 2 plus 1, so the answer is x squared plus 2xy plus y squared. So there are 3 terms, which is x squared, 2xy, and y squared. So there are 3 terms, 1, 2, 3. And for this example, x plus y cubed, there are 4 terms because 3, which is our n, plus 1. So 1, 2, 3, 4. We have 4 terms. Did you get it? Okay, another example. If we have x plus y raised to 9. So the number of terms is 10 because our n here is 9 plus 1. There are 10 terms. Our answer has 10 terms. This statement, the first is a raised to n and the last is b raised to n. So, in this example, as you notice, for example here, x plus y squared. Our a here is the x and our b here is the y. As you can observe in our answer, the exponent or the n in the given expression is the exponent also of the first and the last term. The first and the last term have the same exponent. So, a raised to n for the first and the last is b raised to n. So, since our a here is x, so x raised to n, our n here is 2, so x squared. And our b here is y, so our last term here, or our b, is y squared. So, we will copy the exponent or the n. Do you understand? Okay, so let's proceed. For the next pattern, the exponent of A decreases by 1 for each term and the exponent of B increases by 1. So, we will have an example for you to understand. Okay, so E plus F squared equals E squared plus 2EF plus F squared. For this example, as you notice, the exponent of A here, our A here is E, and our B here represents F. So, the first term, which is E squared plus 2EF, so from the 2 exponent, for the next term, it becomes 1. So, it is understood that it has exponent 1. So, even if there is no 1 here, 1 exponent, it is understood that there is an exponent there. We will not write it anymore. So, plus F squared. So, from the first term, the E here, which represents A, the exponent is 2. In the next term, it becomes 1. So, it decreases. While the B increases. So, from 0, in the first term, there is no F. In the second term, there is an F because it increases to 1. Plus F squared because E here becomes 0 and the F becomes 2 because it increased. So, let's proceed to another example. E plus F cubed. So, the first term is E cubed plus 3E squared F plus 3EF squared plus F cubed. So, in this example, the exponent decreases as you can observe. From 3, in the next term, it becomes 2. While the F increases from 0, here in the first term, it becomes 1. Plus 3EF, the E here, from 2, it decreases to 1. So, we will no longer put 1 in the exponent. While the F, from 1, it increases to 2. Plus, the last term, which is F cubed. So, from F squared, it becomes F cubed. So, it increases. So, another example. E plus F raised to 4 is equal to E raised to 4 plus 4E cubed F plus 6 is E squared F squared plus 4EF cubed plus F raised to 4. So, as what I have said earlier, that from this pattern, the exponent of A decreases. So, the A here is letter E. And the B here is letter F. So, the A from 4, in the second term, it decreases. While the B, which is F, it increases. For the next term, 6E squared F squared. So, from the second term, which is the E here, have the exponent 3. In the next term, the exponent E becomes 2 because it decreases and the F increases. So, from 1, it becomes 2. So, in the next term, 4E F cubed. So, the E here have only 1 exponent, while the B, which is F, our B here is F, so the exponent increases to 3 plus F raised to 4. So, do you understand? Okay, let's proceed. The next pattern is the sum of the exponent in each term is n. So, example, a plus b squared equals a squared plus 2ab plus b squared. So, as you notice from the pattern of the binomial expansion, the sum of the exponent here is the n. So, since in our first example, the exponent here is 2, So, the answer is a squared plus 2ab plus b squared. So, the sum of each exponent represents the n, which is 2. So, a squared. So, we have an exponent of 2. 2ab from the exponent of a is 1. So, it is understood. And the exponent of b here is 1. So, we don't need to write it. So, 1 plus 1 is equals to 2. So, it represents the n plus b squared. So, our exponent also is 2. Okay, for the next example, a plus b cubed is equal to a cubed plus 3a squared b plus 3a b squared plus b cubed. So, from our previous example, we will do it again. So, the pattern is the sum of exponent in each term is n. So, our n here is 3. So, each term, the exponent is also 3, the sum. So, a cubed plus 3a squared. So, 2 plus the exponent of b, 1 here. So, 2 plus 1 is equals to 3. So, it is also 3 plus 3ab squared. So, the exponent of a here is 1 plus the exponent of b here is 2. So, 1 plus 2 is equals to 3 from the given expression plus b cubed. The exponent of b here is 3. So, from the given expression, the n here is cubed. So, each term also, the sum of the exponent is 3. So, let's proceed to the next example. A plus b raised to 4 equals a4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus 4b. So, since our n here is 4, or our exponent is 4 from the given expression, each term, as you can notice, the sum of each exponent is also the n, which is 4. So, 4 from the first term. The second term is 4a cubed b. From 3 plus 1 in b, it is equals to 4. So, it is also 4. In the next term, 6a squared plus b squared, 2 plus 2, which is the sum of the exponent, it becomes 4. So, it is also correct. So, in the next term, 4ab cubed, the exponent of a here is 1 plus the exponent of b, which is 3, is equals also to 4. So, plus b raised to 4. So, as you can observe, the sum of each term is equals to n, which is 4. 3 plus 1, 4. 2 plus 2, 4. 1 plus 3 is equals to 4. The first and the last term has the exponent of 4, so it is correct. Okay? Next, Pascal's triangle. In this Pascal's triangle, it can help you to find the coefficient from row 0 and so on. So, in row 0, since our n here is 0, we have a one term. So, this is what I am telling you earlier. So, 0, which our n here is 0, we have 1 term. And the coefficient here is 1. So, in row 1, 1 plus 1, our n here is 1. So, 1 plus 1 equals to 2. We have 2 terms and our coefficient here is 1 and 1. In row 2, we have 3 terms because 2, our n here is 2. So, 2 plus 1 equals 3. So, 1, 2, 3. We have 3 terms and the coefficient here is 1, 2, and 1. In row 3, we have 4 terms. The coefficient 1, 3, 3, and 1. And the row 4, we have 5 terms. The coefficient here is 1, 4, 6, 4, and 1, and so on. So, let's have an example using this Pascal's triangle. Okay, example 1. the given expression is e plus f raised to 4. So since our n here is 4, so 4 plus 1 is equals to how many terms? So 4 plus 1 is equals to 5. So we have 1, 2, 3, 4, 5. We have 5 terms. And we will using the Pascal's triangle. So in row 4, we have 1, the coefficient here is 1, 4, 6, 4, and 1. So we will use 1, 4, 6, 4, and 1. So the answer for this expression is equal to e raised to 4. We will no longer state that 1e because it is understood, plus 4e cubed f plus 6e squared f squared plus 4e f cubed plus f raised to 4. Okay, next example. I am too fast. Okay. So the next example are given here is a plus 3 raised to 5 is equal to, so since our n here is 5, it is understood that our number of terms will become 6 because 5 plus 1 is 6. So we will use the Pascal's triangle. So our coefficient there is 1, 5, 10, 10, 5, 1. So our given here is a plus 3 raised to 5. So since our n here is 5, it is understood that the number of terms is 6. So 5 plus 1 is equals to 6. So we will use the Pascal's triangle, which the coefficient is 1, 5, 10, 10, 5, and 1. So we will apply the pattern that we discussed earlier. So we will distribute it 1 times a raised to 5 times the b, which is 3 raised to 0. Since 5 is our n, so we will start at 5. In the next term, the exponent of a will decrease and the exponent of b will increase. So from 5 in the next term, it becomes 4. From 0 for the b, it becomes 1. So, and the sum of each term is also the n. So 5 plus 0 is equals to 5. 4 plus 1 is equals also to 5. So 5a raised to 4 times 3, which is our b, raised to 1, plus our coefficient 10 using the Pascal's triangle, a cubed because it will decrease from the previous term, times 3 square because from 1 it increases also. So plus 10a squared times 3 cubed plus 5a raised to 1 times 3 raised to 4 plus 1a raised to 0 times 3 raised to 5. So we apply the pattern that we've discussed earlier. So the sum of each exponent is the value of n, and the exponent of a will decreases and the exponent of b will increases. So we will simplify our answer here. So 1 times a raised to 5 is equals to a raised to 5. The b here, which is 3 raised to 0, so any number that the exponent is 0 is equals to 1. So a raised to 5 times 1, the answer is a raised to 5, plus 5 times a raised to 4, so we have 5a raised to 4, times 3, because the exponent is only 1, so 3. 5 times 3, 15. So 15a, copy the exponent, which is 4, plus 10a cubed times 3 square. So 3 square, we have 3 times 3 equals 9. So 9 times 10 is equals to 90. 90a cubed. So we will copy the exponent plus 10 times a square times 3 cube. So, 3 times 3 is equals to 9 times 3. So, we'll square the 3. So, we have 27. So, 27 times 10, we have 270. A square. Copy the variable and the exponent. Plus 5 times a raised to 1 times 3 raised to 4. So, we will multiply the 3 to 4. So, 3 times 3 times 3 times 3. So, the answer will be multiplied to 5 times a raised to 1. So, our answer is 405a plus 1 times a raised to 0 times 3 raised to 5. So, our answer is 243. So, the final answer for this expression, a plus 3 raised to 5 is equal to a raised to 5 plus 15a raised to 4 plus 90a cubed plus 270a squared plus 405a plus 243. Okay? Do you understand?
Sige.
So, the next example, the given is 5 minus x cubed. We will use the Pascal's triangle and we will use the row 3. So, because the exponent is 3. So, 3 plus 1, there are 4 terms. The coefficient 1, 3, 3, and 1. So, we will distribute it. 1 times 5, which is the a, raised to 3. Or 1 times 5 cubed. Times the b, which is negative x. The exponent is 0. Plus 3, which is our coefficient from the Pascal's triangle, times 5, which is our a, square, times negative x raised to 1, plus 3 times 5 raised to 1, times negative x squared, plus 1 times 5 raised to 0, times negative x cubed. So, as you notice, we apply again the pattern in expansion of binomial theorem. So, from the exponent of a, from 3, in the next term, it decreases. While the b, in the next term, it increases. So, from 0, it becomes 1, and so on. And the sum of each term, the sum of the exponent of each term is equals to n. So, since our n here is 3, so each term, the sum of exponent is 3. So, we will simplify our answer. So, 1 times 5 cubed times negative x raised to 0. So, our answer is 125. Plus 3 times 5 square times negative x raised to 1. So, our answer here, since we have a negative sign, negative times positive, we will have a negative. So, the answer is 75x. Plus, the answer of 3 times 5 raised to 1 times negative x squared, our answer becomes positive 15x squared. Plus, 1 times 5 raised to 0 times negative x cubed. So, since the exponent of the negative number is odd, so the answer is negative x cubed. So, the final answer for this expression, 5 minus x cubed, is equal to 125 minus 75x plus 15x squared minus x cubed. So, questions? None? Okay, very good. Let's proceed to another example. Example 4. Our given here is 2x minus 3y raised to 5. So, we will using the Pascal's triangle. So, since our n here is 5, our answer has 6 terms. So, 5 plus 1 is equals to 6. So from the Pascal's triangle, our coefficient is 1, 5, 10, 10, 5, and 1. So, we will distribute now 1 times the A, which is 2x raised to 5, times our B is negative 3y raised to 0, plus 5 times A, which is 2x raised to 4, because from 5 and in the next term, it will decreases, times negative 3y, which is our B, raised to 1. So, from 0, in the next term, it will increase, plus 10, from the coefficient 10 times A, which is 2x raised to 3, 2x cubed, times negative 3y squared, plus 10 times 2x squared, times negative 3y cubed, plus 5 times 2x raised to 1, times negative 3y raised to 4, plus 1 times 2x raised to 0, times negative 3y raised to 5. So, as you observe, we use or we apply again the pattern for expansion. So, the exponent of A will decreases and the exponent of B will increases. And the sum of each term, the sum of the exponent of each term has the value of n. So, since our n here is 5, so 5 plus 0 is equals to 5. So, 4 plus 1 is also equals to 5, and so on. So, the final answer for this given expression 2x minus 3y raised to 5 is equal to, so, 32x raised to 5, which is the product of 1 times 2x raised to 5 times negative 3y raised to 0, minus 240x raised to 4. Why? Because 5 times 2x raised to 4 times negative 3y raised to 1 is equal to negative 240x raised to 4y, plus 10 times 2x cubed times negative 3y squared is equals to 720x cubed y squared, minus 1080 x squared y cubed, because 10 times 2x squared times negative 3y cubed is equals to negative 1080 x squared y cubed, plus 810 xy raised to 4, because 5 times 2x raised to 1 times negative 3y raised to 4 is equals to 810 xy raised to 4, minus the product of 1 times 2x raised to 0 times negative 3y raised to 5. So, the answer is negative 243y raised to 5. I am too fast. Do you understand? Okay, let's proceed. Okay, for the example 5. So, our given here is a plus 5x raised to 6. So, since our n here is 6, n plus 1, the number of terms in our answer is 7. So, from the Pascal's triangle that we are using, the coefficient of the row 6 is 1, 6, 15, 20, 15, 6, and 1. So, we will distribute 1 from here. 1 times our A, which is also A, raised to 6, times our B, which is 5x, raised to 0, plus 6 times A raised to 5, times 5x raised to 1, plus 15A raised to 4, times 5x squared, plus 20A cubed, times 5x cubed, plus 15a squared times 5x raised to 4 plus 6a raised to 1 times 5x raised to 5 plus 1a raised to 0 times 5x raised to 6. So as I said earlier, we will use again the pattern. So the exponent of a will decrease and the exponent of b will increase. and the sum of exponent in each term is the value of n. So since our n here is 6, so the sum of 6 plus 0 is 6, 5 plus 1 is 6, and so on. So the answer for this given expression a plus 5x raised to 6 is equal to a raised to 6 plus 30a raised to 5x plus 375a raised to 4 x squared plus 2,500a cubed x cubed plus 9,375a squared x raised to 4 plus 18,750a x raised to 5 plus 15,625x raised to 6. If we multiply each term, this is the final answer. So, any questions? Any clarification? Violent reactions? Okay, there is none. So, that would be all for my discussion. Classroom secretary, please take a picture of the screen and send it to me later after our class. And that would be all. Thank you. You can leave now the classroom.